Good morning, afternoon, evening, everyone. Wherever you are, we are extremely pleased to see you on our 5G event hosted from Silicon Valley Innovation Center. My name is Vlas Lezen. I'm a Chief Operating Officer at Silicon Valley Innovation Center, and I will be your host and the moderator for the duration of this session. Today, we're going to talk about 5G. We're going to hear from the wonderful speakers from Verizon, IBM, and Perspecta on what the 5G brings to the future of the business and the global community. Just to give you a little bit of the idea of who we are and what we do, we are Silicon Valley Innovation Center, and we are connecting the global innovation to the global business community. We are bringing the Silicon Valley innovative practices, transformation, and disruption to the companies around the globe. As of now, we have many events that we strategically posted throughout the next few months. As you can see, there are several of the events, and you can join for one of them or all of them for all of our speaker series, virtual conferences, and online programs. We have online programs as well as the separate programs on that. We provide a wide variety of innovative and consulting services on the innovation by leveraging some of the key names in the Silicon Valley and our own bespoke practices. We provide various innovation services across a very wide spectrum of innovation and transformation. We work on the several breakthrough concepts throughout the world, working with the global business leaders, executives, and top companies to help them innovate and be self-disruptors as well as disrupt others. So without further ado, I want to switch to our first speaker, who is a Lav Kher. He is a managing principal at Verizon. And he will talk about the Verizon view on the 5G and transformation that comes from that 5G. Lav is currently Managing Principal and Master Architect in Enterprise Innovation and 5G Solution Group at Verizon, working on emerging platforms and the intelligent edge to create new value and solutions. Earlier, Lav was Master Architect in Advanced Technology Group with global pre-sales, leading SDN and FVF-based advanced networking solutions. Prior to this role, he was Executive Consulting Partner at Verizon. He was offering thought leadership as well as business, strategic, and pragmatic advice in emerging technologies and customers. Most recently, while at AMC Consulting, Lav was responsible for delivering network and cloud virtual data center solutions to customers in Americas. Previously, Lav was GM and Director of Product Management at Lucent Technology, with ATT as Enhanced Service Director and Product Manager. He's an entrepreneur as well. He co-founded and was CEO of two startups in SDN and wireless technologies during his career. Lav began his career at ATT Bell Laboratories. Lav holds a PhD in Systems and Control Engineering from Case Western Reserve University, Cleveland. Lav is settled in New Jersey with his family. He's actively involved in his community, where he serves as the president of the board of trustees. So without further ado, I'm turning over to Lav.
One.
Good afternoon. My name is Lav Kher. I'm Managing Principal and Master Architect in Verizon's Enterprise Innovation and 5G Solutions organization. I'm going to share with you a little bit about 5G and what the future looks like for all of us. I also share with you what kind of 5G solutions we are delivering for companies and the government agencies in the United States. But before I talk about all the 5G solutions and things like that, let me briefly talk about the fourth industrial revolution, which is actually the reason why 5G came to being. And if you look at this diagram, the first industrial revolution, which began long time ago, then the second revolution came almost 100 years ago, and the third again almost 100 years ago. And all these three revolutions essentially changed the economy of the society in the world in many different ways, from mechanical energy to electrical energy. And then finally, the third revolution brought the electronics and the IT wave that we all saw. The 5G revolution, which came about few years ago as a result of discussion at Davos at the World Economic Forum, and it basically predicted that the fourth revolution is going to start in 2019. And we want to share with you what is behind this revolution. What are the technologies that are fueling the revolution? There are fundamentally five technologies which are at the cusp of hockey stick growth, and they are getting really big help from 5G. So the five technologies are artificial intelligence, augmented reality, virtual reality, IoT, video, and cloud. And when you combine the 5G with those 5 technologies, it creates a flywheel effect, which is what is happening, which has started to happen. And again, this is allowing previously unforeseen gains in productivity that we had never seen before. And let me also bring to your attention a little bit about how the wireless technologies evolution started and where we are right now. So if you take a look at 1G, which came sometimes around 1970s, that was essentially able to give us analog voice. And then almost 15, 20 years later, 2G came, that brought in front of us digital voice technology and the text messaging sometimes in the 90s. And then the third 3G, which came in 2001, that is where it got really a lot of momentum and the acceptance in the marketplace with different kinds of smartphones, early stages of smartphones. Many of you may remember BlackBerry, which was very popular in those days, that came around 2001. And then almost 9, 10 years later came the 4G LTE, which brought to us high-speed data and the Internet of Things, which has become really very important for many, many kinds of applications. And now 2019, last year, we were the first one to launch 5G, which is bringing low latency and high bandwidth capabilities that you will be seeing in few minutes, are showing all kinds of promises for us to solve real-time enterprise solutions for the customers. And now let me share with you what is behind 5G. And when we say 5G, Verizon calls it 5G ultra wideband network. Why ultra wideband? Because we use the high band spectrum. And one of the reasons we use high band spectrum is to provide high speed that is needed for many of the applications you will see later on. Other ingredient that goes behind our network is this ultra dense small cell deployment. And without the densification of these cells, it would be very hard to create the infrastructure. So we have been doing the densification for a long time, even in the time of, and we are taking advantage of that densification. And then it is very important to manage the capacity and throughput of the backhaul. And you have to ensure that the right kind of fiber is implemented. And we have been implementing fiber in the major markets within the US. And we will have almost 60 major markets that will be covering fiber end to end in the US, spending a lot of money in this project. The next important building block is called new radio, which is basically required for the purpose of the millimeter wave. We cannot use the older technology of the radio. Newer technology is needed to support that high band spectrum which we are using. And there are many things that are important in the new radio. I'm just going to focus about two important ones. One is the massive multiple input, multiple output bays that house the antennas. And basically, these MIMO technology allows us to transmit almost 22 times more signal compared to what we are able to do in the 4G LTE. Second important thing that I would like to mention here is the beam forming. One thing that is important is to make sure that we have some technical capability which allows us to minimize the interference of the signal, and this beam forming, which is essentially creating a very tiny beam 6 degree wide that goes from point A to point B, and the data gets transmitted in a full duplex or flexible manner. The next building block, which is also very important to share, is the software-defined networking and network function virtualization. These technologies are needed because we are virtualizing the entire network end-to-end for 5G. This is the first time it is happening in the wireless technology, and without that, it is practically impossible to have this kind of a large-scale deployment. In this, there are a couple of important things. I will just mention one item out of the interest, and that is the network slicing. My next slice will cover into a little bit detail about what the network slicing is all about. I also want to mention that coupled with this network is the multi-access or mobile edge computing platform. So once we have that, then this whole network becomes network and compute fabric. It's no longer simple network fabric. So let me share with you now what exactly network slicing is all about and why is it important. So think about this as a capability that we are introducing in the 5G network. This will, by the way, come next year, is the capability of having the mobile network which has the virtual channels in it. So in other words, similar to the virtual private networks, within the large network, there will be virtual channels. Each channel is basically representing one slice. I'm showing here 4 slices. That is just pictorially. It could be more than 4. But the idea behind this is to create these slices so that each slice can be dedicated for a specific set of application, which warrants us to have certain kind of quality parameters to be included. So for example, mobile broadband may have one slice. And mobile broadband, if we are using video streaming or some applications that are requiring us to have high bandwidth. So this slice could be dedicated for high speed and low latency kind of quality of service characteristics. Machine to machine communication typically does not require high speed. So this slice could be having low speed and low latency kind of characteristics, thereby ensuring that end to end we will achieve the kind of SLAs and the QoS that the customer is expecting. Another is the mission critical application, which is going to be the one that may perhaps require low speed and very low latency. These are the autonomous guided vehicles that could be used in different locations. So the idea behind this is that we create virtual circuits inside this network or slices inside this network. Each slice is going to give us the guaranteed quality of service and the security that it requires. Now let me share with you Verizon's perspective on what are the 8 different capabilities, or we call them as 8 currencies, that make the 5G so unique relative to the relative to 4G and things like that. So if you take a look at this diagram, there is a lot of things written here, very busy, but nonetheless, I'll try to justify and make it very simple. So if we start from the top, this is one time we are able to see that we can achieve up to 10 gigabit per second of data throughput. And why is it important? Because there are certain applications which require that kind of a bandwidth, whether it is immersive content streaming or the AR, VR, 4K kind of data video files have to be transmitted. Now, if we go in a clock fashion, latency can be achieved up to 5 milliseconds. And again, depending upon many other factors, and that kind of a low latency, in this case, we are showing even for the consumers who are interested in gaming applications, you definitely need low latency. Reliability in the case of 5G now, first time we are able to achieve 5 nines of network grade reliability, which is very important in the manufacturing, production environment, autonomous vehicles, and things like that. Service deployment can be reduced to 90 minutes. We want to have real-time face recognition or real-time translation of language from one language to the other, things like that. And then comes the mobility. 5G specs are designed to work at the speed of 500 kilometer per hour. And there are many applications which may require that kind of speed, such as high-speed trains, or when the aeroplanes are taking off or landing, you would need that kind of a speed. And then drones and the autonomous guided vehicles connected with robots may require in certain situations that kind of speed. The next attribute or the capability is the data volume. Because of this high band that we are using, we are able to support 10 terabyte per second per square kilometer of that kind of a volume of data, which is very, very important to be able to have that, especially when we are deploying in the smart stadiums or the applications that we will show you later on, intelligent video and localized AI, ML kind of applications. This is one important thing that will bring us to massive IoT. And why I'm saying that? Because now in 5G, we can support up to 1 million devices per square kilometer. That is massive, massive. And this is going to revolutionize in many industries such as oil and energy, or any large manufacturing plants where a lot of IoT devices are connected there. Last but not least, we all have to be concerned about the planet Earth sustainability. And good thing is that 5G allows us to achieve the energy efficiency by virtue of just consuming 10% of the current energy consumption that we have. And there are many technical capabilities that allow us to do that. Now, these are the capabilities or the platforms we are deploying above the connectivity layer: intelligent video analytics, artificial intelligence, and immersive creation and consumption. I will show you later on certain use cases that we have developed, and we are doing some trials. But the idea is that the ability to have near real-time ubiquitous intelligence, that changes the game that we are all in, especially in the manufacturing, retail, communication medium, healthcare, and you name it. Many kind of verticals require these kind of capabilities, and you will see the use cases where it will become important. So the point I want to emphasize is that it is one thing to have the 5G connectivity, but it's totally another thing to have a platform that can support these kind of new technologies, which are part of the 4G, fourth industrial revolution. So before we go too far, I want to just briefly mention what is edge computing, because we will be using that term quite a lot in the next 10, 15 minutes that we have. There are traditional clouds, which we are familiar with, commercial cloud service providers that provide all the compute and storage capability. In that, if you see, this is the left-hand side. The devices are connected through local area network or wireless, and then goes to the compute fabric, and then whatever is required is done by the applications. But because of the distance, the latency is much higher there. So these kind of solutions are not suitable for real-time enterprise solutions that we have been talking about. Whereas if you have a distributed cloud, which means that the compute, i.e. the mobile edge compute platform, is sitting next to the radio antenna, and therefore very close to the end devices, you have the compute fabric literally next to it, and therefore the latency becomes very, very attractive, which is what I mentioned about 5 milliseconds or something around that time. So that's how we are enabling the real-time enterprise solutions that many of the enterprise customers and the governments are looking for. Give you a small example of video analytics. This is just an example of, let us say, in a city infrastructure where 5G is deployed, high definition video can be sent uncompressed over 5G to this MEC platform where the video can be analyzed for the purpose of safety, for the purpose of any kind of unwarranted situation that may be there, or in a factory environment, any kind of anomalies in the production line. So the analytics are done locally as opposed to far away in the cloud, and then the insights are shared with the appropriate people who are basically managing the city or a production facility. So you get the idea that how this is going to help. Now let me switch over to the deployment status. As of February of this year, we had basically deployed in 34 cities 5G nodes. You can see that. And we have plans to complete almost 60 markets before the end of this year. You can see that we launched service in 2019, April 3rd. We were the first one in Chicago and Minneapolis. Along with that, we have also lit almost 20 stadiums for various kinds of sports activities and made them smart stadiums by virtue of deploying 5G antennas there. This graph basically shows the value and the bandwidth requirement and responsiveness requirement for various kinds of applications. If you're talking about simply Wi-Fi phone, you see that very low bandwidth and how high latency is acceptable. But when we are talking about drone, for example, you need a lot more bandwidth and less latency is required. So this just gives a pictorial view of the art of possibility that we have with the 5G technology. Give you briefly example of many of the use cases that I said I will be talking about, and basically if you see that in this diagram, we are enabling 5G based business internet offer. So this can be done through outside antenna receivers or inside receivers or receivers on the window, etc. And we can provide the kind of internet circuit which will have high bandwidth and reasonably low latency that would be required by the customers, 30 millisecond and things like that. And the benefits of these are same as whatever benefits customers are used to with respect to the broadband internet that they get from different ISPs. But now this can be expedited and be very quick, and we don't have to wait for a long time for the deployment of the circuit. In addition to the 5G broadband internet, we also are about to launch private LTE and private 5G networks, which are going to provide many different kinds of business benefits to our enterprise customers as well as our customers in the government sector. So one is that by having a private cellular network, they are going to get dedicated network which they will be able to control as they wish to control. It is not going to be shared with any other customer, and therefore it will provide a lot more bandwidth and a lot more coverage that they are looking for. Second benefit is the high performance, because now I am responsible for controlling any kind of application that I want to have, be that low latency application or medium latency application or whatnot. So I can once again control the quality of service with my private network because I am managing and controlling it. Third is the seamless mobility. So one can go in and out of private and public network very easily in many different situations. That is what customers are looking for. And then again, this is the right pathway towards 5G. 5G is in two flavors. One is non-standalone architecture that we have today, which basically leverages the LTE anchor band for uplink kind of services, and therefore uses the LTE core. And then later on, the standalone 5G architecture will be there when both the radio and the core will be all 5G, and that will enable all kinds of things, such as the slicing capability that I had mentioned. There are many customer trials that are going on. These are the four key verticals that we see from the enterprise side, where there is a lot more action, whether it is retail, manufacturing, healthcare, or entertainment. Especially, we see a lot of excitement in the manufacturing and retail, healthcare, etc. Yes, provide a lot of opportunity. I'll share with you one or two examples here. In the manufacturing, a lot of customers are interested in quality of their product. Therefore, they want to identify any kind of potential defect or any kind of anomaly in their product. In this case, the product shown is some kind of a fiber, or it could be any industrial complex, whatever that may be. And we are working with many of them. The other important thing for manufacturing is the ability to have predictive maintenance so that they can minimize the outage in the plant and therefore increase the productivity and reduce the cost. Retail has a lot more applications with respect to shelf inventory automation or the digital objects that can be created with augmented reality. And you go to the healthcare, lot of usage now, especially in the COVID-19 situation. Remote patient monitoring is very critical. And this is, I'm not saying it's a perfect timing, but a lot of people are using it for that. And then the remote healthcare systems where immersive video collaboration is needed when they are doing some kind of a surgery and they want to consult with an expert who's elsewhere. Is for the airports where they want to expedite the check-in process, and we are doing the facial recognition to make sure that the crowds can move through pretty quickly from these facilities. Now we are also going to be doing some kind of a heat mapping to ensure that we can detect anyone who has any kind of a symptom, and those applications are being worked as we speak. This use case is about managing your supply chain, how to control what packages are coming, going, and this has number of companies which are interested. Third-party logistic providers are very keen on having a 5G and MEC-enabled environment where they can track and audit all kinds of products that are coming and going and automate that whole process. Now coming to the public sector, we have these four areas within the public sector where we have a lot of work going on. In the interest of time, there's not a whole lot I can discuss, but let me just say that public safety is number one use case that is being used in many areas within the cities as well as in different other locations through the augmented reality, real-time intelligence capabilities, and remote asset operation. So there is a lot of work going on with respect to public safety and the education, where Verizon is donating quite a number of units and things like that for the training and education purpose, and which is becoming very critical now that everybody is working from home, even the children and the adults who are working from home. A lot of capabilities are required, and we are supporting a lot of colleges and schools with these kind of capabilities. Let me sum it up briefly that building the 5G enabled future is not a trivial task. We believe that we have not only the core products, that are needed from the connectivity perspective, intelligent edge perspective, but we want to make sure that the solutions are such that can be applied and implemented to different environment regardless of what kind of a sector the customer is coming from. And on top of that, we offer the managed services. So the solutions are managed end to end, and therefore customer doesn't have to worry about what exactly they have to do or they don't have to do given the technology, whether it's a 5G or the different platforms are all so new. So managed services make a lot of sense, and we unify our internal teams and work with the customer to build the service journey with the customer. Now, I want to leave everyone with a positive note about the market forecast, but I want to caution that this study was done by an analyst. We don't have any say in that. And this was done in 2019. So their forecast was based on 2019's situation of the world. Obviously, the world has changed in the last 2.5, 3 months. So please take these numbers with a grain of salt. But nonetheless, the market is pretty attractive. So what they are saying that in 2035, which is 15 years from now, the global total value chain because of 5G will be around 3.6 trillion US dollars. And the various countries distribution is shown here. I'm not going to go in the details of all of that, but it's a huge, huge opportunity. Even if the market will be less or will slow down, nonetheless, it's going to be a pretty big market. The other forecast that they did was that the 5G will enable 13.2 trillion US dollars in global sales activity in 2035. Long horizon, and that's pretty big. And they have given the breakout by the various industries, by various kinds of major use cases that are out there. Let me summarize and say that three main industries will take more than 50% of the opportunity. Number one is the manufacturing, number two is information and communication, and number three is wholesale and retail. Last but not least, Verizon has various 5G labs within the US, 5 of them, and one lab in London. The New York City lab is the one which was the first one, has a lot of demonstration. The idea of these labs is to create collaboration with the various academia, NGOs, startups, enterprises, etc. And then we do the co-creation, co-innovation with them. We have a lot of ideation and incubation hackathons and do a lot of games and prizes are given to the startup companies. London lab was opened just a few months before COVID. This is just a slide that shows a lot of activities that we have in New York City lab. And with that said, I want to close my presentation and I want to thank Silicon Valley Tour for giving me the opportunity to present. And now I'm open for any questions that you may have. Thank you very much.
All right, we just heard a wonderful presentation from Love Care, and he is ready to answer all the questions that we saw on our chat. And without further ado, we are switching to Love Care. Hello, Love. How are you doing today? Can you hear me?
Yes, I can hear you. Thank you.
Awesome. Thank you so much for this presentation. It definitely was a great overview of both technological and business use cases for 5G and what changes it can bring. We have several questions that have been happening on the chat, and some of them has been actually already partially answered by our audience. So let me start with the first question here.
Yes.
Yeah. So we have you. I think you already covered. Our first question was about the 60 major markets, and I think you already covered it in your presentation. So I think we're good there. So, and the question that people have is that with so many devices in a relative small area, how's interference being managed? And we have several answers, including from our next speaker, Zygmunt, who said the 5G new radio is designed to minimize the amount of chatter on the on-air interface. And then there was also an answer that MIMO creates beam for each device handset to reduce interference. Could you please talk more a little bit about it? How do we handle interference? And also, kind of on top of that, how do we handle a peak bandwidth for those large gathering of people when they're all trying to stream or maybe talk or do something like that?
That's an excellent question, Vlas. Appreciate that. So let me talk about the question about the interference. So one of the way we handle interference is there is a capability in the new radio called beam forming. So what beam forming does is it creates a 6-degree beam which goes from point A to point B in a very directed fashion.
Oh, I see. And then what about the peak throughput? How can we handle this peak throughput in terms of many users are trying to stream or use the 5G or their mobile network in the high throughput scenarios?
So that is where it comes down to how do we design the network, and the network is designed in such a way that each of the new radio will have the ability to transmit the millimeter wave signal that we are basing our 5G. It basically creates the ability that we can we can transmit.
Okay. And then there was also a question about the security. So is there could you please speak on the security behind 5G? So what are the security concerns behind 5G infrastructure, especially when you said there could be first responders using maybe some military or law enforcement agencies? Is there a way to kind of have a both more secure and less secure, but maybe faster network for various applications throughout different use cases?
Yeah. So security is something that is handled inherently in the 5G's specifications, as well as the idea of having the slices that we have, or even without the slices, the devices that will be used. Devices will have their own authenticated SIM cards, which will ensure the security.
Awesome. And then also people are wondering about the health concerns about the 5G, having it more so intense, having it much more productive, much more throughput. Is there any kind of health concerns or anything that might interfere with our current operation, be it regular radio waves or maybe some health concerns? Can you say about anything that a lot of questions are asking about the a lot of people are asking about the questions regarding the health and interference with the regular life.
Yeah. No, again, a great question. A lot of people have concern about health, but I can tell you that anytime a radio equipment is released by the vendor and used by service providers like us, it gets through the clearance from FCC for the emission rate that it sends. So far, all the studies that have been done have been very positive. There is no health concern.
And then a question about the energy. So could you please tell us how it's possible that if it consumes less energy both on the receiving and the sending side, how it's possible that we can handle such a high throughput by using less energy?
Yeah. So the Yeah. Again, the energy consumption is less for all the devices compared to what those devices are used with 4G LTE. And the design of the specifications and the reason, one of the other reason is that since this is connected with mobile edge computing, lot of the compute that is done typically today is on the device. And now with the new environment of 5G with mobile edge computing, the heavy duty compute will be done on the compute device. Therefore, the consumption on the device for energy would be much less.
I see. I see. Well, love. I think this is the all the questions that we had so far. Oh, we also had a cool question that what are the top use cases for telemedicine? You talked to us about the usage of health patient monitors, but can you say maybe one or two more where 5G really brings the difference to the game of the telecomputing telemedicine?
I'm sorry, I could not hear the last question as there was some echo here.
Oh, can you tell us some of the use cases for the telemedicine? What are some of the you said the uh, healthcare monitoring for the patients as well as the telesurgery. Can you name a couple more?
You mean for the healthcare industry?
Yes. Yes.
All right. So obviously those two use cases which I have listed in my basic. Yeah. Yeah, I mean, now the other use case that is coming up very recently is with respect to doing the infrared monitoring of the person's health.
I see. I see. Well, love, thanks so much. It was very informative, and thanks so much for answering our questions. We will be switching to our next speaker, and thank you so much for sharing your insights about the uh, about such a interesting use cases of the 5G and giving us a fantastic overview on how 5G will affect the future of many industries. Thanks so much, love.
Thank you.
Our next speaker is Zygmunt Lazinski. He's from IBM, and Zygmunt is a senior technical staff member in IBM's global telecom and media industry responsible for SDN and FV strategy. Zygmunt consults to operators on technology and strategy. He defined the data center and network data center strategy for a global mobile operator to shift to cloud. He also developed the network strategy for an operator in response to the deployment of the nationwide fiber infrastructure. He was part of the team that delivered the NFV infrastructure for a major operator. He's a member of the EHCI, NFV, and ONAP security workgroups. He has 30 years experience working in North America, Europe, and Far East. He led the development of advanced platform for caching, traffic shaping, and CDN at the mobile network, the origin of MAC. He's an IBM senior technical staff member and an IBM master inventor with over 25 field patents. Without further ado, we're switching to Zygmunt.
Hello, and welcome to this session on 5G, the network cloud, and the enterprise edge. I'm Zygmunt Lazinski, and I'm from IBM's telecommunications industry, based actually in Cambridge, here in the UK. I'm going to spend the next 30 minutes describing to you how 5G is going to revolutionize the communications services that you see over the next 10 years, both for consumers, but also how it will change enterprise communications, how it will lead to a new set of applications and services delivered from the edge of the network, and how it will be based, how 5G will be based on a cloud infrastructure rather than the traditional network infrastructure that we've seen up to now. So let's look in a little bit more depth at 5G, what you can expect and when you will expect to see it, and what type of services that we'll be receiving. So the vision for 5G is that there will be a vast array of new services available. Those include, for example, voice communications as we have it today, but much higher quality video communications for video calling, but also video for delivering over-the-top type entertainment services. The high capacity of 5G means we can download large amounts of data very quickly. But as well as that, we also are looking at industrial applications, for example, robotic, healthcare, and providing information, for example, to autonomous vehicles. And it's these enterprise use cases that are actually really important, because there's a general belief in the industry that consumers expect technology to improve over time, and that they won't pay more than they currently pay for 4G for their new 5G service. And the investment that's required to build out a new 5G network is measured in the billions of dollars. And so operators are dependent on revenues from those new enterprise services in order to justify that build out. So why now? Why has 5G suddenly come about? Well, basically, every 10 years, it's cost effective to deploy a new set of mobile technology as microelectronics technology improves. And we've been through 4 generations up to now. The standouts were 2G, the first global digital mobile communication standard, and then 4G. 3G was a bit of a commercial disaster in that there was a lot of money spent on license fees, but the technology wasn't really able to live up to the promise, whereas 4G has been outstandingly successful. And we're now looking to see, with 5G, improving on that success. Now, the use cases that we talk about for 5G are around faster internet, the Internet of Things, and industry applications. And they have particular names. So enhanced mobile broadband is faster mobile internet, this idea that you may be able to access between 1 and 10 gigabits per second of data. Of course, the important thing from the operator's perspective is lots of people can access high capacity data, so that brings the cost down. 5G has been optimized to allow many more devices to enable the Internet of Things and to enable industry applications like robotics. Again, from the operator's perspective, one of the things that's really important about 5G is that it's based around cloud technology to make the implementation of the network significantly cheaper and to bring the cost down, thus enabling operators to serve more all customers. Okay, so let's look at the use cases in a bit more depth. The first one is enhanced mobile broadband, and the idea here is that there's at least a headline rate of between 1 and 10 gigabits per second for every device. This is going to be the first use case that we will see deployed, and it will be used for web browsing, for video calls, for video streaming. There is another potential application for enhanced mobile broadband, though. In rural areas where it's not cost effective to deploy fibre, 5G can be deployed as a fixed radio bearer to allow connectivity for small underserved communities. The other advantage of 5G mobile broadband is it doesn't require you to replace the core network. You can roll out new radio towers and connect them to the existing 4G network, and that's very attractive for the operators. Now, the dependencies on mobile broadband are that we have a broad range of chipsets. Well, that's true. Qualcomm released their chipsets in sort of 2018, 2019, and that there are mass market devices, and we would expect to see those come to market this year. A slightly unusual application of mobile broadband is this example from France, where Orange, as a test at last year's French Open tennis, equipped a set of broadcast cameras with 5G uplinks to enable them to stream very high quality video from the tennis tournament, and that was a sort of a first stab at trying to do something slightly different with the high bandwidth that's available. The second use case for 5G is around the Internet of Things, which is called massive machine type communications, and this use case is really designed to enable us to have 2.5 million devices in a square mile. And what it does is the radio within 5G has been redesigned so that it's much more power efficient, so devices don't need to continually transmit to remain on the network. That potentially means battery life for embedded devices is much longer. And because the radio has been redefined so that devices are not continually going, I'm here, I'm here, I'm here, that chatter reduces the power requirement, but also means you can support more devices. Now, obviously, for Internet of Things type applications, low cost per device is critical, and one of the debates there is around the cost of the essential IPRs, the essential patents to implement a 5G device. The sort of applications we are expecting to see will be around Industry 4.0. So, for example, factories, automating robotics, automating robots in, for example, a warehouse. And those applications typically require higher spectrum frequencies than are used normally to support consumer applications. And that leads to an interesting question. What would happen if an enterprise were to support its own 5G network? And we're seeing that happening in some countries already, for example, in Germany. This is an interesting example of a use case for IoT. Those robots, this is an example in Germany where the Deutsche Telekom are running a 5G network for the Osram manufacturing plant, and those robots that you can see there are all connected via 5G, and they move around the factory looking to receive instructions, but also to exchange information with the infrastructure around them. Okay, so the next use case for 5G is around ultra-reliable or low-latency communications. And again, the headline here is around the requirement to support a millisecond latency for access to the network. Now, this use case will require the upgrade of the core network, which will happen over the next few years. Again, for ultra-reliable communications, if we're doing things like augmented reality or virtual reality, you can see why latency is important. Another potential application, though, is for the emergency services or first responders who want to be able to do group type push-to-talk services within a closed community, but to do that on a public infrastructure rather than on a special purpose infrastructure that's just for them. So we've seen FirstNet in the USA, and that type of technology is likely to be deployed in other countries. And of course, low latency communications is also potentially applicable to telemedicine. And indeed, this example is from Japan. This is a pilot that NTT Docomo built in Japan, and one of the things that they were exploring was whether or not robotic surgery was a potentially viable thing to do. So, let's sum up. What is 5G? Well, it's the next generation of mobile communications technology. You should expect it to dominate the next decade. For consumers, it'll give you faster broadband. For enterprises, this will support billions of IoT devices and robotic type applications in the factory. And for operators, 5G will reduce the cost by between 4 and 10 times. We should expect that 5G will dominate the next decade. We're already seeing operators starting to deploy the new radio. It takes roughly 7 years to cover a country, so that process will continue. That will start in the major cities like Manhattan, like Dallas, like San Francisco, and then rural areas will get served later. And then the new core will probably start in a couple of years' time, again, based on cloud technology. We're going to see 5G deployed globally, and it will obsolete and it will completely replace 3G. There is no point in having a 3G network anymore. 5G is just a more efficient way of working. And we're seeing both operators running spectrum licenses and operators actually raising money to pay for networks and spectrums right now. Thank you. Next, let's look at some real-world use cases for 5G services and also at how they're actually implemented in practice. The Italian government believes that 5G is potentially a source of competitive advantage, and so they've sponsored operators to build early 5G networks in major cities like Milan and Rome. And they've asked those operators to work with their partners to develop some industry-specific use cases to demonstrate 5G's value. And they've actually published the results. Those are available online. And IBM worked with Vodafone in Milan on a set of industry use cases, and I'm now going to describe some of those to you. There were 6 specific cases that we built. I'll highlight them. One was around supporting medical students. One was around supporting people as they entered hospital. One is around remote monitoring of patients. One around railway station security, smart agriculture, and finally, health food. Now, each one of these has quite a lot of depth associated with it, so we'll look at perhaps 3 of them. But one of the interesting things that one of our partners, who was the Vodafone director who involved, was observing that this required new ways of working. This was much closer to an agile software development project than perhaps in the past building communication services. So the first one we'll look at is around safety for consumers in railway stations. Now, everyone's concerned with large public spaces, firstly that they be safe, that people don't be subject to harassment and attack, but also people are worried about terrorist attacks and whether somebody has left something untoward there. So what we did is build a solution that enabled us to combine video from a set of cameras located around the central station in Milan, and then to perform processing of the video to detect abnormal events and to flag those up to Security Operations Center. And the thing that's particularly interesting about this is obviously video takes a lot of bandwidth. So what we've done here is we've used the IBM Video Analytics platform, which is a machine learning based video analysis package, which has two components. One part of it you train using the resources available in a cloud, but you run the video analytics model in a much smaller location in a mobile edge computing node attached to the 5G cell tower. So that node is looking to see there's an object on the platform that I don't recognize. I mean, people move around the platform, they get on trains, but this suitcase has now been here for, say, 5 minutes. I'm going to flag that up to the Security Operations Center. Another application area is around agriculture. Obviously, high-value crops are worth investing more in. Soft fruits, one example, vineyards, olive groves. There, it's worth putting in additional effort to monitor the crop and to take action if action's required. And so in this case, again, we have a set of drones that have cameras, we have a set of other sensors that are available, and we have information, for example, about the weather and the properties of the soil. And this basically, Watson for Agriculture, again, connects to the cloud on the one hand, but actually, again, runs in a mobile edge computing load as part of the mobile network, where it can receive video from drones, for example, showing it what's going on in the fields. And that enables us to actually make recommendations. Now might be the time to change the watering regime. Now might be the time to harvest this plant, or this crop, even though it's perhaps early. Another example is to use video analytics to actually improve food quality. Now, in this particular example, this is a food manufacturer, it's a bakery, and what we've done in this case is we've again built a video analytics model, a machine learning model, allowing us to look at product, in this case bread, as it's going through a production line, and the camera knows when the product's at the right stage, and so each individual thing can be taken off the line as it's ready. And this particular example is a good one because the idea of processing video data locally, for example, in a semiconductor manufacturing line, data about the product being produced would never be allowed to leave the facility. So the ability to have information processed locally is actually very important for manufacturers. And then the final example is where we have a robot, and in this particular case what we're doing is using the Watson speech and natural language processing ability to enable us to interact with people as they enter a hospital, because obviously that's quite a stressful time, and to actually help them just get used to the new environment. We've looked at the use cases for 5G. Let's now think about how the network itself is implemented. I mentioned that the network now uses cloud technology, so let's see how that's done. In the past, a mobile network had tens of thousands of radio towers connected back to perhaps tens or of centralized sites that ran the core network. Each of those sites was a separate, had its own infrastructure, had its own physical appliances that provided the network, the function of the mobile network. What's happened over the last 10 years is that the operators have decided that in order to reduce the cost of running the network, it's important to move away from physical appliances, but towards a common cloud layer that is distributed across both radio sites, regional sites, and the core, that provides both virtualization and in future a container platform, and that horizontal infrastructure then runs network functions as software components. And this is called network function virtualization, and people sometimes call it software-based networking. And this is how 5G networks will be built. And we've seen, for example, recent announcements by Rakuten in Japan that they are deploying their 5G network in this way. And at the Red Hat Summit 2 weeks ago, Verizon described how they were going to use the Red Hat Open Container Platform as the cloud native infrastructure layer for their network. So the idea is that we have this common managed cloud, and the reason this works is because it gives a common way of managing many different network functions, many different pieces of software, and the benefit is in common automation and in a common orchestration platform that enables you to deploy new cloud workloads, new network functions wherever they're needed, and to deal with upgrades and incidents like the failure of a node or the failure of a link. So operators are building these horizontal carrier grade clouds, and what's happening then is that the network equipment vendors are delivering software that provides network functions. So if you think about how a mobile network works today, you have the radio nodes, and all those radio nodes are then connected to what's called the packet core, which is basically a very large proxy server that has tens of thousands of connections to radio sites on the one hand, and connections to internet peering points on the other hand. And that's a good scale-out workload, so it's well suited to running on a cloud platform. It authorizes users to use the network, and then connects their device to the internet. But this concept, this idea of a distributed telecoms cloud, also allows us to think about putting workloads other than the network workload on some of those nodes. And we've already mentioned the idea of edge computing, and that a telco may be able to support edge applications running as part of the network. And if you looked at the examples of the 5G use cases in Italy, each one of those was implemented using the telco network to provide an edge platform with this common cloud management layer to deliver those services. And the benefit, of course, is common platform means reduced management cost, and that's the real benefit, that over time a single platform will provide for all network applications and potentially also for IT applications. We've talked about the edge and what edge applications might mean in the context of a 5G network. Now let's look a little bit more detail about how those might actually be built. It's clear that there's a lot of demand from enterprise customers for decentralized IT, and analysts basically say that they expect that there will be a large amount of processing that goes on close to these new Internet of Things type devices, and therefore we need to be able to handle those new types of workloads as we have more sensors and more devices. And if we think about the types of industries that will be impacted, edge computing will affect all industries. Financial services, obviously, with how payments are processed, while at the same time maintaining data integrity and keeping in tune with the financial regulations. Clearly, in the automotive industry, edge applications potentially, like an autonomous vehicle or a smart vehicle, will potentially have lower costs and a better experience for the customer. Anywhere there's a self-service device, obviously that's another example of an edge application. Healthcare has its own challenges, but in particular, the protection of data is absolutely essential. We've talked about manufacturing and the importance here. We can build video analytics type applications that will run at the network edge. The important thing, of course, is that those images never leave the location where they're taken, because they are quite sensitive. They show the state of a manufacturing line or even of products that have not yet been announced. So the ability to perform video analytics at an edge node without transferring the data to the cloud is attractive to manufacturers. In the logistics industry, of course, robotics and the ability to automate the handling of robots locally is important. And of course, we see pay by the hour as an insurance application. But if we think about all of those use cases, there are some common things. First of all, there are very large numbers of devices to manage, and we want to be able to build the edge applications using common tools and technologies from the IT world. And we can think about the different elements that we need to be able to deal with to support an edge platform. The network edge itself, which is where the communication service provider, the telco, provides resources as part of their network, which may include edge servers. And then there are the actual devices themselves. Some, maybe a smart camera, for example, and some of those devices may actually have some computability themselves, whereas there are sensor devices that don't have any ability to compute. They just need to be able to relay information either to an edge node or to the cloud itself. But we've got to be able to manage all of these nodes, and we've got to be able to build applications that support them. So what IBM has done is determined that we need to provide a management capability, a platform that allows us to design, to deploy, and run applications and analytics across all of the different type of edge locations, whether it be edge in a service provider's network or edge in an enterprise location, but in a common way for all of those locations. And so you need a management function that can autonomously manage the deployment of edge applications and provide you with the ability to do operations of those applications, but also provide security for them, because it's critical for any enterprise service, especially if it's running in an infrastructure not directly controlled by the enterprise itself, that the security be assured. And so this is based on an OpenShift container-based platform, and we believe that by allowing enterprises and enterprise developers to put business logic, to put machine learning workloads close to the edge of the network where data is originated, that will make for more efficient applications and mean that you don't have to ship large amounts of data across the network. So, we've seen what 5.
All right. All right, I think we are ready to go. Zygmunt, thank you, thank you so much for your.
Close to the edge of the network where data. Hello, sorry.
No, that's quite right. We have Zygmunt who is ready to answer our questions. And without further ado, I'm switching over to you. Hi, Zygmunt. Thank you so much for sharing your perspective on what has been done. And it is really interesting to see how big companies like yours can collaborate with the network providers. And we have several questions, and you've been very active on the chat. But let me probably ask you this. So in a lot of cases, what we see is that there is a lot of bandwidth on the sending side. But then let's talk about the edge computing. If we have this edge computing that is very close to the origination of the data, and this edge computing receiving not only data from the one device, but from the many devices in the area, how can receiving side handle those through bandwidth, and how we can ensure that all the data that comes from all of those devices is being processed properly?
Okay, so with mobile edge computing, what happens is that we attach a server, an edge server, at or close to the cell site. And so it has access to all of the bandwidth from the devices that connect to the cell. And the reason we do that is because that then we process the information locally and only send the results to the rest of the network. So that saves on the uplink bandwidth into the rest of the network. And because the mobile edge server is close to the cell tower, it also means that there's a very low latency between the devices that are looking for service and the application or service they're running.
And thank you. And then in terms of transmitting the data, so you said that one of the key features of the 5G is reliability. And as we all know, there's always could be some issues with that, right? So for those mission critical applications, is it possible that you can share not only one network provider, or maybe across several network providers? Like in the real life, some of the big companies, they'll have two wires coming into their building, so we can switch in case one of them is having issues. So is there a capability, something like that?
So 5G introduces an idea called network slicing, which allows us to take a horizontal slice of resources through the entire network, from the radio site, transmission, and the core network, and to dedicate those to a single application. And the way to think about that, the simplistic way of thinking about that is, so the Ford Motor Company has a network slice dedicated to its automobile, whereas BMW has a different slice. The most likely first deployment of network slicing will be for things like first responders or emergency communications, where we dedicate a slice and the resources so that function's always available. For example, like FirstNet in the United States, where police, fire, ambulance services have a dedicated communications service that is prioritized above you or I making a video call for very good reasons. So that's how let's see that happen in the first wave of 5G.
I see. That is very interesting. So in terms of cooperation across several of the companies, right? So we have obviously the carriers who build all of this, but what about other companies like IBM or Tesla, maybe anyone else? What is your cooperation model for the network providers to enable all of those computing possibilities for your clients and for the general public?
I think that what we will see with 5G is, because it's based on using cloud technology within the network as well as outside the network, that it will rely on, or its success will be dependent on an ecosystem of partners, both network operators, the vendors who build networks today, but also new companies that build applications and services and want to integrate those with the network. So I would expect to see a more complex ecosystem of partners who actually make both the underlying 5G infrastructure, but also the new applications and services that run on top of it work together.
This is very interesting. And then in terms of pricing and the build out, so obviously carriers are building the network, they are putting the capital expenditures into that. Is there any kind of revenue sharing, or maybe some kind of the payments for using this 5G, or it's pretty much a case by case basis for, let's say, for the automakers and for those slicing, as you said?
So I think for consumer services, those are likely to be priced much as they are priced for 4G. I mean, I can't speak to operators' strategies, but it's clear that consumers will have monthly bundles as they do with 4G. I think for the more complex enterprise use cases and those that involve network slicing will be priced and marketed much like complex enterprise communications are today. So the major operators, Verizon, AT&T, have groups that specifically create complex services and provision those for enterprise customers. And those are often, there are a bundle of standard offerings, but some of them are priced on an ad hoc manner just because they are one-offs.
I see. And then in terms of, thanks so much. And then in terms of guaranteeing, let's say, for some of those critical connection, whose responsibility is to actually guarantee that compute, guarantee that data transformation, guarantee that whole connection framework? Whose responsibility? Let's say if I'm a client, right, and I come to IBM
Sure.
about the edge computing, and you guarantee me, or are you guaranteeing me certain SLA for delivering and processing this data?
So you'll typically have a service that involves both a network operator and someone who provides the edge computing. And yes, I would expect that enterprises will receive SLAs, and that will be managed through a combination of the network operator and potentially any edge partners that they choose to use. Because the enterprise needs an SLA, they'll get one.
Great. And then in terms of kind of fitting 5G into the fiber optics and also some of the maybe space solutions, let's say your satellites and all this, is there any kind of intersection, or can they work together? Can they complement each other, or they kind of work in parallel and there is no really intertwining between those technologies?
Okay, so 5G for consumers is gives you a mobile access technology in the same way that fiber to your home gives you access to the network. 5G is dependent on there being a fiber infrastructure that connects the cell towers to the network. Now, space is interesting. I was at a meeting last year where we were looking at the use of 5G delivered from low Earth orbit spacecraft to deliver communications to critical infrastructure projects. And the example that was used is the chief engineer of Britain's latest motorway, which is about 5 miles from my house. And he was saying, we are building out infrastructure, and when it's finished, all of the motorway gantries will have wireless access points. But while we are building the infrastructure, we are completely isolated. And so and I have built, he said, the biggest cement plant in the country. But I need to be able to get data for my enterprise applications that I need to build the civil engineering infrastructure while we're constructing things. So there's a lot of interest in using the space sector and the space segment from Earth to low Earth orbit to deliver 5G data services in particular spectrum bands for remote enterprise use cases. And you can also think about how you might use that for an oil exploration field. where again, you may not have the fiber infrastructure that you might otherwise use.
Thank you. This is really interesting. And then in terms of the build out, does it have to be like a 5G and 5G only, or is there some kind of 4.5, 4.7, 4.8 going forward? Is there some kind of gradual build out, or it's all or nothing kind of deal?
So what the design point for 5G is that you can either build out what's called a 5G standalone, which is where you build a greenfield from scratch 5G network. And some countries will do that if they're licensing a new operator. The most likely scenario is what's called 5G non-standalone, where you deploy new 5G radios. Those give you additional bandwidth, and you connect them in the first instance to a 4G core network. And then over time, you increase the number of 5G radios, you eventually deploy a new 5G core based on cloud technology. And then as the 4G devices in your country reach end of life, you can then think about repurposing the 4G sites to be 5G only. But that process is going to take 10 plus years because we don't want to obsolete devices that consumers have paid good money for.
Awesome. And then probably the last question, what has been your feedback, and maybe how can you gauge the appetite for those new technologies and new applications from the other users of possibly those technologies? Is there like a huge interest? Is everyone saying that, yeah, it might be a good idea, but not necessarily the best, and we need to wait? What is the interest from the general public and from the business public as well?
I think in terms of the consumer market, everyone just wants better video. As we saw today, people just want better video on their iPad or their iPhone. Okay, and consumers just will expect to get a better service over time. I think the real interest around 5G is coming from the enterprise community and from governments who are saying, well, how can we use a pervasive infrastructure like this? What additional capabilities can we offer? Like that was the reason for the Italian experiment. It was to say, well, what services can we build? And can we now work out what's the business case for these services? And we're seeing the same in the USA. The White House is asking, well, what's the position of 5G with regard to the competitors of the US industry? Yeah, you're seeing the same discussion in European countries too. So I think the radical use of 5G is going to be as those enterprise services come along. I mean, we've already got things like Ring doorbells. We will see as autonomous and smart vehicles become more pervasive, they're going to need communications pretty much all the time. Those are the sorts of things that will change. But like the internet, I mean, if you think about it, the internet was here 25, 30 years ago, just wasn't very widely distributed. What 5G does is make those sorts of enterprise applications cost effective. So you can do those things today, but not very many people benefit. The benefit to business is when everybody gets to use them.
Absolutely. It's a classical network effect that the more people use it, the more benefit you get. Zygmunt, thank you so much. It was extremely useful and extremely informative about not only the use from the carrier perspective, but also how can you build on the infrastructure that 5G provides. Zygmunt, thank you so much. I know you should be late in UK, so have a wonderful evening and have a wonderful upcoming weekend. Thank you so much.
Thank you, everyone. Stay safe.
Thank you. Our next speaker is Tony Triolo from Perspecta. Dr. Anthony Triolo, he's a research director at Wireless Advanced Technologies and Perspecta Labs. Dr. Triolo serves as director of the Wireless Advanced Technologies Laboratory at Perspecta Labs. As director, Dr. Triolo is responsible for programs related to custom uses of commercial cellular equipment and other high-performance signal processing and software-defined radio programs. He is currently principal investigator of the NCC cellular range telemetry effort, where Perspecta Labs is developing uplink that allows COTC 4G 5G equipment to be used to provide aeronautical telemetry service to aircraft traveling at speed up to Mach 2. He is responsible for the device-to-device for public safety (DDPS) effort, where his team is developing an open source standard based implementation of 5G infrastructure communication to enable first responders to communicate with each other when cellular infrastructure is down. Dr. Triolo is also leading several other efforts to adapt cellular equipment to operational in contested tactical environments. Over the past 20 years, Dr. Triolo has provided leadership to many wireless technology areas such as propagation, measurements and modeling, spectrum management systems, dynamic spectrum access system, and distributed multi-antenna signal processing.
Okay, I'm coming to you today from beautiful New Jersey, sporting my quarantine haircut or lack thereof. And I've been told to go into a quiet room to do this. But since I have 4 children, a dog, and 2 cats, a quiet room does not exist in this house. But anyway, today I'm going to talk to you about how 5G can be used for DoD and public safety. But before we start talking about 5G, I wanted to go over a little bit all of the previous Gs, starting way back in 1983 with the first wireless mobile system called AMPS. The thing to take away from this slide is if you look at the differences between these systems, the main differences exist in the area of throughputs. If you look, we started off at 2 kilobits per second way back with AMPS, and 5G, we should be able to get up to about 1.5 gigabits per second, which is extreme difference going from 1983 till 2020. The other main point to look at is in the key features row. For most of the other generations of wireless mobile, the concern was mainly with voice. In 4G, we started to talk a little bit more about streaming video and broadband video, but all of the generations before 4G, voice was really the driver for the system. But if you look at 5G, it's not just broadband that we're concerned with. It's also many other services. In the column there that says primary application, you look at the 5G column and you see enhanced mobile broadband, ultra reliable low latency communications, IoT, and voice to every vehicle to everything. So 5G is designed to handle many different types of use cases. However, it was not designed for applications like the Department of Defense, military applications, or even public safety. That was not one of the primary drivers behind the designs for 5G. So what are the weaknesses for 5G and cellular in general as they relate to military and public safety use? One of the weaknesses is that these standards really don't support very high vehicle speeds. So in military applications, we're talking about possibly supersonic flight if you're doing ground-to-air communications. 5G is not designed for that kind of a speed. It was designed mainly for high-speed rail applications, which are fast, but not quite as fast as, say, a supersonic aircraft. One of the other weaknesses that both 4G and 5G were designed for downlink heavy communications, that is from the base station to the handset, or UE as we call it in 4G, 5G terminology. DoD uses include a bunch of different uplink heavy applications. I'll talk about one in the next couple slides, but as you might think, if someone is carrying around, let's say in a tactical use case, carrying around a UE to use for seeing into a room where they just walked, that could be video coming from the handset to the base station. It could be telemetry from an aircraft, which is the application I'll talk about next. But in either case, it's not really from the base station to the handset That is the primary data driver in these use cases. Long range operation is limited. The 4G, 5G standard is a cellular standard. It's got a practical maximum range of 100 to 150 kilometers based on what's in the standards and what's implemented. In the DoD use cases, what we've seen for, say, the telemetry application that I just mentioned is that you could require ranges where you're doing testing of aircraft over the sea that exceed 200 nautical miles. So that's also a far cry from the 100 to 150 kilometer limit. Device to device operation without infrastructure is limited in the standards. The V2X part of the standard does come close, but that's really designed for vehicle to vehicle or vehicle to infrastructure. In the public safety case, for instance, or even in a tactical use case, you would want your UEs or handsets to talk to each other when they go out of range of the base station. For instance, if you have a team of public safety folks going into a building, they may not have access to the signal coming from the base station, but they still want to talk to each other throughout the building. That's really not supported in the standards. And another big limitation is that the cellular standards, including 5G, were not designed to handle interference. These standards were designed for operators, cellular operators, to operate in licensed spectrum. They're not designed for the case of, say, the tactical environment where there may be somebody intentionally jamming you, or you may have lots of interference from things that are out of your control. You're not operating in licensed spectrum. So these standards were not designed to handle that kind of interference. So how do you get around these limitations and still take advantage of the economies of scale that you get, the short timeframes to new technology you get with 5G and other cellular standards? There are three main ways that I'll talk about here in this talk. One is the use of appliques, and in this case, it's hardware appliques for the most part. Use the devices as they exist, use the standards compliant devices, get those economies of scale, but overcome their limitations with a external device that you can attach to these to help you accomplish what you need to accomplish. And those external devices obviously can't be things that are very, very expensive because it defeats the purpose of using some of these standardized technologies. So you have to keep that in mind when you design these appliques. Another way to get around it is work to add or to modify this to the standards. That would be standards involvement, which takes lots of time and lots of man hours to do. And it also doesn't guarantee that it's implemented. Just because it's in the standards doesn't mean that someone that makes the device is going to implement that part of the standards. And that's something we've seen over and over again. Another way to take advantage of all the work that was done in the standards, but do something that's semi-custom, is to do a software-defined radio-based open source implementation. Since the open source community has been keeping up with the standards and has implemented lots of the features and stack of the cellular standards in their open source frameworks, take advantage of that and use those on software-defined radios. Here's an example of how we address some of the weaknesses for the high-speed airborne mobile telemetry environment. This is based on a project that just concluded where we implemented a 4G-based transceiver to do airborne mobile telemetry from a supersonic aircraft to the ground during test flights. As I said before, extreme speeds and channel conditions differed compared to, in this case, we implemented this with LTE, but we're now transitioning that into a 5G framework. High Doppler shift and rapid handoff between cells is something that is not seen in a standard cellular network. Our applique that we developed takes the high Doppler and compensates for it in a way that allows you to use standard 4G or 5G equipment to still maintain your link in supersonic conditions. Another problem that we had when we started this project was that the bands that are licensed to the government to use for mobile telemetry during test flights did not have equivalents in the 3GPP standards, which means that there was no equipment in those bands that we could get. Our solution used unbanded equipment and multi-band equipment that we found from niche providers, but we are now developing a device-independent frequency translator that allows us to use this same cellular equipment in these telemetry bands. As I mentioned before, asymmetric link is another problem that you run into using standard equipment. That's because we have a high rate, 20 megabits per second, from the air to the ground, which in this case would be from the UE to the eNode B. So we overcame that problem by using some of the configurations that are available in LTE, and there are even more in 5G, that allows you to optimize for one link versus the other. It doesn't get you quite as far as you need when you need extremely high rates, but it did suffice for the 20 megabit per second target we had. So this slide shows the Doppler compensation applique that I just mentioned. And in the bottom right of the slide shows our Doppler compensated UE mounted in a pod on a supersonic aircraft. And the LTE base station that we use, the outdoor ruggedized LTE base station that operated in the C band, which is not a 3GPP band, it's 6 gigahertz band that is used for telemetry applications. Shown on the bottom bottom left, the way that the applique works is that as the signal is transmitted from the base station to the UE, it arrives Doppler shifted by quite a bit. What we do in the applique is detect how much the Doppler shift occurred on that part of the link and shift it 2 times in the opposite direction so that when the signal is transmitted back to the base station, it arrives at that base station with no Doppler shift. And what we've seen is that we laboratory tested with speeds between Mach 2 and Mach 4, depending on which carrier frequency you use, since the Doppler shift is proportional to the carrier frequency that you're operating on. And our applique was able to handle those types of speeds, which are extremely high. We installed this equipment at Edwards Air Force Base, and we just recently flight tested successfully. We plan to continue with flight testing at Edwards Air Force Base as over the summer and into the fall in order to do even higher speed testing. And we're working to integrate our Doppler compensation method into a commercial product. So here's another example of limitations that you run into when using standard equipment for non-standard applications. Despite standardization in the V2X arena and for device to device, there was never a commercial device that implemented this device to device part of the standard. It's called ProSe, or proximity services. It's been in the standards for quite some time in LTE, but there was never a chipset manufacturer that manufactured a device that could do this type of device-to-device communications without infrastructure. If you look at the picture on the right there, you'll see the standard type of arrangement for wireless or cellular communications with an eNode B at the center. I think I can get my mouse. eNode B at the center here with first responders scattered around. Typical cellular networks will have all of these UEs attached to the middle eNode B. If someone roams out of range of this eNode B, they get disconnected and have no signal. This can happen frequently in first responder use cases where people enter a building, there's lots of path loss through the building, they lose communication with the eNode B, but yet they still have to communicate with other first responders. The ProSe part of the standard would allow that to happen. There's a couple of different ways that this can happen. If you see here, SideLink is the part of the standard that says one user can talk to the other without a base station. And then you also have relay where you can relay, one person gets disconnected from the eNode B, but he can relay his signal through other first responders. This was standardized, but never implemented. So we undertook a program to actually implement this part of the standard in a software-defined radio. We have a test bed that we set up that demonstrates the feasibility of this type of communication for first responder applications. The way we did this was implementing this in open source software using software-defined radios. There's a few open source software stacks that implement the 3GPP standards, both 4G and 5G, or at least parts of 5G, since it's still kind of early. But one of them is called Open Air Interface. We developed building on the Open Air Interface stack, an application that actually implements the ProSe standard and demonstrated over the air in an outside test and also in laboratory tests that this part of the standard works well for these types of first responder applications. There were lots of problems to solve, including how do you do time synchronization between people that are disconnected from the network, since the eNode B really is the master clock in a cellular network. It maintains synchronization with all devices connected to it. If you have a bunch of devices that disconnect from the eNode B, they have to now synchronize time among themselves. And this is very precise synchronization for synchronizing on the physical layer for the waveform to actually work. We developed a novel multi-antenna based synchronization solution to do this that performed very well. But this example is one that shows that you can actually overcome some of the limitations of what's been implemented in devices by doing it in a software-defined radio approach, and then taking that software-defined radio implementation, shrinking it into something that can be attached to a standard UE, maybe in the form factor of a sleeve, like one of those battery packs that you add to the back of your phone, except in there it has software-defined radio and can implement these types of device-to-device communications, for example. There's also lots of parts of the standard, in 5G especially, where they've added lots of different options and different use cases to be handled. For instance, there were some mobility enhancements that were introduced into 5G over and above what was in LTE to increase the robustness, which means reduction in interruption time for high speeds. This feature is currently in development in the standards, which means it's going to be quite a while until it gets put into practice. But it does reduce the interruption time using make before break in the handover from eNode B to eNode B. If you look at the graphic here on the bottom right, this shows that an aircraft is flying above from leaving the range of a source eNode B or GNode B in 5G terms and coming into range for the target GNode B. This make before break mechanism reduces the amount of data loss when handover occurs. In previous parts of the standard, it was a break before make mechanism, which could introduce some either extra latency or data dropout when handover happens. But this does not address the high Doppler case directly, but there are other parts of the standards that could help with that, including what's called flexible subcarrier spacing, where you can actually space the subcarriers in the OFDM waveform apart further so that you can accommodate higher Doppler shifts. Another part of the standard that was recently introduced is called non-terrestrial networks part of the standard. This extends the cellular standards to include high altitude links and satellite to ground links or ground to satellite links. There's been lots of interest in this part of the standard, and it's upcoming in release 17 of the standards of NR standards, which stands for New Radio. That's part of the 5G standard that introduces lots of new concepts into the radio part of the link. And so this type of part of the standard was meant to accommodate links between train and airplanes and say LEO, MEO, GEO satellites, or even high altitude aircraft. The pre-specification enhancements that are currently being drafted include how do you do time and frequency acquisition, how do you do timing advance extension, since that really is the major part of the standard that breaks when you're trying to do these very long range, high altitude links. Timing advance is what's used to tell the UE how much to advance its signal so that when it arrives at the E node B or G node B, it's lined up with transmissions from all the other UEs to avoid them interfering with each other. There's a limitation in the current 4G standard that limits that timing advance, and there's some other conditions in the standard that limits how far you can get. And so what we've actually experimented with is that, and seen, is that we can get between 100 and 150 kilometers from the base station. But we've been approached by folks in the telemetry community that say that that's not enough for their application to use 4G or 5G. They actually want to get 200 nautical miles. So one of our thoughts is to use this non-terrestrial network standard, this part of the standard and this part of the implementation when it eventually gets implemented, to do terrestrial networks that can accommodate the long delays to do 200 nautical mile links. So you could use this part of the standard in a non-conventional way to solve some problems that exist for the DoD. So this is where we're looking into this and are looking into doing some network emulations and emulations in our lab to see if this part of the network or this part of the standard can help us to get those long range links. Another introduction in 5G new radio, 5G NR, is both using millimeter wave bands, which was not used before 5G standards. Millimeter wave bands allow you to build lots of antennas into a small package. And what do you get when you build lots of antennas in a small package? You can form lots of beams. So this is this part of the standard sometimes people refer to as massive MIMO. It's using on the order of 64 or 128 or 256 antenna elements on both ends of the link to form very narrow beams that point from the G node B to the UE. In this case, it's represented by an aircraft. But those very narrow beams are useful when you're talking about a military or tactical use case where someone may be interfering with you. When you have a point-to-point link that has very high directional gain between two ends of the link, if someone is off to the side trying to jam you, they get rejected by this beam. So you don't even see this interferer that's coming from the side because you're pointing towards the UE. And unless that interferer is directly behind the UE, the interference level that you get from all other directions is highly reduced. So that is not the intention of this part of the standard. This part of the standard was not put in there to avoid jamming or avoid interference. Really what it was doing is trying to get the gain in the direction of the user to be higher to make up for the fact that millimeter wave bands, propagation in those bands is worse than it is for the low bands. And you actually have lots of path loss over these millimeter wave links. And the only way you can close these links is by using these high gain antennas in order to close the link toward the user. But a side effect of that for a use case in a tactical environment is that you do get this interference rejection. This is an example of using the standard in another non-conventional way to address applications that weren't initially thought of as the standards were being developed. So these another actual side effect of this also, besides rejection of interference, this is this low probability of jamming, is this low probability of intercept and low probability of detection. So just as if someone is off to the side trying to inject energy into your link, they can't do it because of your directional links. If someone is trying to listen for you, in this case, trying to detect you or intercept your communications, if they are not in the direct line of this link, the amount of energy that they will see is reduced to the point where they won't be able to detect your signal or even intercept it. So that's also falls into the category of a non-traditional use of the standards, something that was put in the standards for one reason, but used now for military application. So the question when it comes down to it is, do the 5G parts of the standard, or does 5G help for military and public safety uses? When you look at all the press around 5G, it really is being touted as everything for everybody. In the case of military and public safety, they were not really in mind when these standards were introduced. But the 5G standard does introduce many different concepts that can be used in non-traditional ways. Military environments have to assume that their environment is contested. 5G was not designed for this type of use. As I said before, intentional jamming was not part of the thought process when these standards were being developed. But as I just said, built-in beamforming can help you there. The externally directed beamforming and nulls help. The PROSE, or device-to-device part of the comms system that was introduced originally in 4G is now included in the vehicle-to-everything part of the Release 16 standard. However, it's not meant for a tactical use case. It's meant for vehicle-based comms and might not necessarily help when you're talking about tactical use cases. There's lots of things that you need to worry about that were not part of the V2X standard. So this is where standards work helps keep public safety use cases in mind. For instance, I have a group of folks in my department that work for the Office of Emergency Communications. They attend all the standards meetings. They keep the use cases of the Office of Emergency Communications in mind and make sure that there's nothing put into the standard that would cause a problem for emergency communications. They also introduce new things into the standard to help with emergency communication priority services. That's an example where you can actually get involved in standards for these use cases and help drive something into the standard. There are then other parts of the standard that were, as I mentioned before, used for different reasons, such as the non-terrestrial network part of the standard, but it doesn't fully address the long-range terrestrial links. You could develop a special use variant using standard equipment in a non-standard way to accommodate these very long-range links. So these were just examples of how you could use what's in the 5G standard for different use cases, ones that were not initially thought of when the standards were developed, and other ways of using standards-based equipment in non-standard ways. Thank you.
All right, that was a presentation by Tony Triolo. He talked about very interesting aspects of applying 5G to diverse first responder and defense communication. So without further ado, I'm turning over to Tony, who's ready to answer all of our questions. Hello, Tony. How are you today?
I'm fine.
Awesome. So thank you so much for sharing for sharing the insights about very interesting and very demanding tasks that your company solves. So I have a question from kind of myself. When you said that the government has the broadband and the bandwidth associated to their needs, are they using a special 5G, pretty much every government building their own 5G, or they're leveraging some of the commercial solutions that are being built out?
So the government has their own spectrum in which they can operate, similar to what the service providers have. The service providers have paid for licenses to use 5G or whatever technology they would like. It's LTE right now, but increasingly 5G. The government has its own spectrum allocation where it can do whatever it needs. Right now, the government is considering using 5G for many different applications, including the ones that I talked about, and also for doing things like smart warehouse operations, providing service to military personnel on bases. So they recently have issued requests for proposals to companies to provide those services to the government. And they're looking for solutions that are not just coming from traditional defense contractors, but also from private industry does regular cellular deployments, and they're looking to do this to basically to save money and leap ahead in technology, and also help the U.S. to become more involved in 5G, both equipment manufacturing and also innovation. So the government is trying to use what they can from the commercial providers as is, but like I described in the talk, there's lots of cases where they can't use that equipment as it exists for consumer cellular, but they need to do some special applications.
Mhm. And then we have a question from the audience that kind of a little bit of the segue. Can you quickly share, if you can, again, about the 5G legato controversy, or in general, I assume that from what I can see from the news is that is there a balance between the dialogue and some things that need to be enforced from various government or maybe first responders applications?
So yeah, it's been pretty contentious in the 5G community as far as imposing restrictions on certain manufacturers from outside the country versus manufacturers from inside the country. But the government is trying to walk the tightrope there. There aren't many, or actually there aren't any U.S. companies that manufacture cellular infrastructure equipment like the base stations within the US. All the companies that manufacture this infrastructure equipment are foreign companies. So the government, from what I've seen, is trying to still purchase equipment from countries other than the US, but also maintain security.
Sorry, the network just dropped, so let me go back to the right. Here we go again. Sorry for the interruption. I guess some of that manufacturing was a problem for a second. Yeah. So I think the last thing that we ever heard is that the government is trying to balance between the security and manufacturing something in the in the country. So a question on that, on the follow-up question on that is, what is currently being done for the U.S. to be more competitive in this 5G space? Because a lot of the electronic manufacturing is being outsourced to the outside parties.
So there's been several efforts recently within different parts of the government. One of these efforts to try to operate through some of this equipment that may be untrusted is run through the National Spectrum Consortium, and they are issuing requests for proposals to find solutions that allow them to use equipment from anywhere around the world, but still be able to trust their communications. There's concepts called zero trust networking, where you can operate your network in a secure way, even though you don't trust the underlying equipment. So those types of efforts are being undertaken by the government and funded, and they're also trying to fund people within the U.S. to develop technologies that may eventually become 6G, or find ways of improving on 5G in ways that suit the needs of both military first responders. And so they're funding some of these efforts right now within the US.
And probably the last question. So, kind of following up on all of this. So, how likely that the Department of Defense and other first responders are going